This is Teacher Sarah, and today we are going to discuss simple and general annuities. This video tutorial is based from your learning activity sheets in General Mathematics Quarter 2 Week 3. So bring out your learning activity sheets and turn your learner's module to pages 168 to 188. Our learning targets are illustrate simple and general annuities, distinguish between simple and general annuities, and find the future value and present value of both simple and general annuities. Before the lesson, let us have some warm-up questions. I have some questions for you to answer. Question number 1. Give examples of payments where people pay by installment. Time starts now. Okay, here are possible answers. Insurance payments, major purchases, that is appliances, property, or loan payments. Check. Question number 2. How do this payment done? Times starts now. Answer: periodically or in equal amount. Check. Okay, class, so today we are going to discuss this scheme of payments. People pay by installments, such as in insurance payments, major purchases like appliances and property, or loan payments. Payments by installment are done periodically and in equal amounts. This payment scheme called annuity. So annuity, the type of annuities, these are the lesson that we are going to discuss today. Given below are the important definition of terms that will help you recognize the annuity. Annuities may be classified in different ways as follows: according to payment interval and interest period, according to time of payment, and according to duration. According to payment interval and interest period, the annuities is simple. If an annuity where the payment interval is the same as the interest period. General annuity is an annuity where the payment interval is not the same as the interest period. According to time of payment, ordinary annuity or annuity intermediate is a type of annuity in which the payments are made at the end of its payment interval. Annuity due is a type of annuity in which the payments are made at the beginning of its payment interval. And according to duration, annuity certain is an annuity in which payments begin and end at definite times. Contingent annuity is an annuity in which the payment extends over an indefinite or indeterminate length of time. So the term of annuity represents T, the time between the first payment interval and the last payment. Regular or periodic payment represent R is the amount of its payment. The amount or the future value of an annuity, F, is the sum of future values of all the payments being made during the entire term of the annuity. Present value of annuity, represent P, is the sum of present values of all the payments to be made during the entire term of the annuity. Annuities may be classified as simple and general annuity. Below are examples of simple and general annuities. For simple annuity, the installment payment for an appliance at the end of each month with interest compounded monthly. For example, Jean plans to save money for the future. She will set aside 5,000 pesos at the end of every 3 months and put it on an investment company where her money will grow by 3.5% quarterly. She will do this for 30 years. For general annuity, the installment payment for an appliance at the end of each month with interest compounded annually. Another example, Anna intends to borrow money as capital for her business. To pay it off, she will pay 3,000 pesos at the end of every month for 6 years. The money is compounded by 5% quarterly. So the main difference is that in a simple annuity, the payment interval is the same as the interest period, while in a general annuity, the payment interval is not the same as the interest period. Annuities may be illustrated using a time diagram. The time diagram for an ordinary annuity is given below. So phi stands for the present value, F is the future value, and R is the regular payment. Then this number referred to N or the term or time or period. To find the future value of simple annuity, so let us have an example. Suppose Mrs. Santos would like to save 3,000 pesos every month in a fund that gives 9% compounded monthly. How much is the amount or future value of her savings after 6 months? Identify the given. R refer to regular payments amounting 3,000 pesos. T or the time is 6 months or 0.5 year. R is 9% or 0.09. N equals MT, which is equal to 2 times 6, and that is equal to 12. So you ask to find F or the future value. So for the solution, your step 1 is to illustrate the cash flow in a diagram. So where phi and F are the present value and the future value respectively, then in the cash flow diagram, so 1 year to 6 years equal payment. The regular payment is 3,000. So second step is to find the future value of all the payments at the end of the term, where T equals 6 months. So one basic concept is the time value of money. An amount such as 3,000 at T equals 1 has a different value than 3,000 at T equals 2 or 3,000 at T equals 3, and so on. This means that if we consider interest, we cannot just multiply 3,000 times 6 equals 18,000 because each of the individual 3,000 payment is valued differently from the others. The correct way to find the total savings at the end of 6 months is to compute the maturity value of each 3,000 at the end of 6 months. By the end of 6 months, the 3,000 at T equals 1 would have earned interest for 5 months. The 3,000 at T equals 2 would have earned interest for 4 months, and so on. So for the third step, you add all the future values obtained from the previous steps. And these are the values. Okay, when you add them, it's give you a sum of 18,340.89. So thus, the amount of this annuity is 18,340.89 pesos. Okay, to find the future value of an ordinary interest, so the derivation of formula in finding the amount of an ordinary annuity is similar to the solution of example 1. So refer to the diagram. So this is a cash flow time diagram. Okay, from the cash flow time diagram, so you find the future value by getting the sum of their regular payment in each month, and you name this as equation 1. Then you multiply both sides by 1 plus j to get f times 1 plus j equal to r plus r times 1 plus j plus r times 1 plus j raised to the second power, and so on and so forth, and you name this equation 2. From equation 1, you subtract equation 2 to produce f times 1 plus j minus f equals r times 1 plus j raised to n minus r. Then you multiply, or you factor rather, you factor. So from the left side of the equation, the common is f. So you divide each term by f to get the other factor. So that becomes f multiplied by quantity 1 plus j minus 1 equals, here on the right side, the common is r. So divide each term by r to get the other factor. So r times quantity 1 plus j raised to n divided by r. So that becomes 1 plus j raised to n minus r divided by r is 1. So therefore, when you simplify, so f times j equals r times 1 plus j raised to n minus 1. So to simplify further, f equals r times quantity 1 plus j raised to n minus 1 divided by j. So where r is the regular payment, j is the interest rate per period, and n is the number of payments. So note that j is equal to 1 raised to m over m, or that is equal to, where y raised to m is the annual rate of interest and m is the frequency of conversion. So applying this formula in our example, j equals I raised to m over m, where I raised to m is the annual rate of interest over frequency of conversion, where the annual rate of interest is 0.09 and the period or frequency of conversion is 12, so j is equal to 0.0075. So the formula for f was derived based on the procedure on how to accumulate the payment of each period to the end of the term. So f is equal to r times quantity 1 plus j raised to n minus 1 all over j. So to solve the problem. So you just replace the factors, the given factors in the formula. So F equals 3000 times quantity 1 plus 0.0075 raised to 6 minus 1 divided by 0.0075. So F, or the future value, is 18,340.89. So for example 2, in order to save for her high school graduation, Marie decided to save 200 at the end of each month. If the bank pays 0.25% compounded monthly, how much will her money be at the end of 6 years? So the given, we have the regular payment R, 200, T equals 6 years. R is 0.25% or 0.0025, and M, or the frequency of conversion, is 12 since it is compounded monthly. Then find F, or the future value. So first, solve for the value of J using the formula. So our J is 0.000208. Then solve for N, where N is equal to product of MT. M is 12, number of years or term is 6. Then N is equal to 72 periods. Then applying in the formula from F equals R times quantity 1 plus J raised to N minus 1 over J, substituting or replacing all the given values, F is equal to 14,507.85 pesos. So hence, Marie will be able to save 14,507.85 for her graduation. Let us now discuss how to compute present value of a simple annuity. Example. You recall the problem in example 1. Suppose Mrs. Santos would like to know the present value of her monthly deposit of 3,000 pesos when interest is 9% compounded monthly. How much is the present value of her savings at the end of 6 months? So the given are the regular payment. R is 3,000 pesos. T is 6 months or 0.5 year. Rate of interest is 9% or 0.09. Then M is equal to 12 since it is compounded monthly. So in the diagram for step 1, discount the payment of its period to the beginning of the term, that is, find the present value of its payment. So look in the given diagram. So for step 2, you add all the future values obtained from the previous step. So that is equal to 3,000 times 1 plus 0.0075 raised to negative 1, and that is equal to 2,977.667. Then 3,000 times 1 plus 0.0075 raised to negative 2 equals 2,955.501. Then we have 3,000 times 1 plus 0.0075 raised to negative 3, and that is 2,933.50. Then 3,000 times quantity 1 plus 0.0075 raised to negative 4 equals 2,911.663. Then we have 3,000 times 1 plus 0.0075 raised to negative 5 equals 2,889.988. Total, when you get the sum of all the future values obtained from the following, so the present value is equal to 17,536.79. Thus, the cost of the TV set at the beginning of the term is 17,536.79. Instead of using the very long formula in finding the present values in this problem, so we have an alternative solution to that problem. So since we already know from example 1 that the accumulated amount at the end of 6 months is 18,340.89, then we can simply get the present value of this amount using the formula below. P equals F over quantity 1 plus I raised to M over M raised to MT, where MT is N. By substitution, replacing the value of F, or the future value, which is equal to 18,340.89, so over quantity 1 plus 0.09 over 12 raised to 12 times 0.5. So to simplify, P is equal to 18,340.89 divided by quantity 1 plus 0.0075 raised to 6. Therefore, our P, or the present value, is 17,536.89. So this formula is already derived from the formula for present value at compound interest, that P is equal to F over quantity 1 plus I raised to M over M raised to MT. And if you want to study how to get this formula of present value of an ordinary annuity, the derivation of the formula in finding the amount of an ordinary annuity is similar to the solution of example 3. So look at the given cash flow time diagram. No? To get the present value, you just add all the future values. No? Then you name this as your equation 1, and then you multiply both sides by 1 over quantity 1 plus j to get P over 1 plus j equals R over quantity 1 plus j raised to the second power plus R over quantity 1 plus j raised to the third power, and so on and so forth. And you name this as your equation 2. From equation 1, subtract equation 2 to produce this value. So finally, P is equal to 1 minus R times quantity 1 minus quantity 1 plus j raised to negative n all over j. So the future value of an ordinary annuity was given earlier by F equals R times quantity 1 plus j raised to n minus 1 all over j. And to get the present value of this amount using the formula, P equals F over quantity 1 plus I raised to M over M raised to MT, or that is equivalent to P equals F over quantity 1 plus J raised to N, where J is equal to I raised to M over M and N is equal to MT. It is obtained from finding the present value at compound interest. So that is an alternative solution to find the present value in example number 3. So therefore, if you replace all the given values the present value is equal to 17,536.79 pesos. Let's have another example. Mr. De La Cruz paid 200,000 pesos as down payment for a car. The remaining amount is to be settled by paying 16,200 at the end of each month for 5 years. If interest is 10.5% compounded monthly, what is the cash price of his car? The cash value or cash price is equal to the down payment, if there is any, plus the present value of the installment payment. So the given in the problem are down payment 200,000, regular payment is 16,200, time is 5 years, rate of interest is 10.5%, and the frequency of conversion is 12 since it is compounded monthly. So then find the cash value of the car. So using the formula for fee to get the present value, so you replace the given in the formula where R is 16,200 multiplied by 1 minus quantity 1 plus 0.00875 raised to negative 60 over 0.00875. Note that the 0.00875 or the J is computed using the formula J equals I raised to M all over M. So that's why we have this value 0.00875 for the value of J. So fee is equal to 753,702.20 pesos. So to find the cash value, so since there is a down payment, then down payment plus the present value, you add them, so that the cash value of his car is 953,702.20. For general annuity, the formula for the future value is given by F equals R times quantity 1 plus J raised to N minus 1 over J, while the present value is given by P equals R times 1 minus quantity 1 plus J raised to negative N all over J. Note that these formulas are the same as those of simple ordinary annuities. The extra step occurs in finding J. The given interest rate per period must be converted to an equivalent rate per payment interval. Recall that J equals I raised to M over M, or that is equal to annual rate of interest over the frequency of conversion. So to find the future value of general annuity, let us have an example. Mel started to deposit 1,000 pesos monthly in a fund that pays 6% compounded quarterly. How much will be in the fund after 15 years? So first step is to identify all the given values, where R equals 1,000, R equals 6% or 0.06, M is 4, and N is 180 because N is calculated as the product of M and T, where M is 4 and T is 15 years, so that is 180. Then you ask to solve for the future value. Since payments are monthly, the interest rate of 6% compounded quarterly must be converted into its equivalent interest rate, that is compounded monthly. So our first step is to convert 6% compounded quarterly to its equivalent interest rate for monthly payment interval. So equating that f sub 1 is equal to f sub 2. So by substituting the formula as f sub 1 is equal to P times quantity 1 plus I raised to 12, since it is monthly, over 12 raised to 12 times T is equal to f sub 2 is equal to P times quantity 1 plus I raised to 4 over 4, since it is compounded quarterly, raised to 4T. Then using this computation, finally, to get for the value of J, our J is equal to 0.00497521. So that means the interest per monthly payment interval is 0.497251%. Substituting J to the formula, F equals R times quantity 1 plus J raised to N minus 1 over J. So the value of F is equal to 290,082.51 pesos. Thus, Mel will have 290,082.51 in the fund after 15 years. And to get for the present value P in general annuity, our formula is P equals R times 1 minus quantity 1 plus J raised to negative N all over J. So you just substitute the value in the formula. Another example, Rene borrowed an amount of money from Cathy. He agrees to pay the principal plus interest by paying 38,973.76 each year for 3 years. How much money did he borrow if interest is 8% compounded quarterly? So again, the given are the regular payment is 38,973.76 pesos. R is 8% or 0.08. Frequency of conversion is 4. N is 3. So find the present value. So using the same process in example number 5, you first solve for the value of J, assuming that we already solved for the J, which is equal to 0.082432. Then substituting all the given values in the formula to solve for the present value of general annuity, P equals R times 1 minus quantity 1 plus J raised to negative N all over J. So our P is equal to 100,000 pesos. Hence, Rene borrowed 100,000 from Cathy. Another, Mrs. De La Cruz would like to buy a television TV set payable monthly for 6 months, starting at the end of the month. How much is the cost of the TV set if her monthly payment is 3,000 and interest is 9% compounded semi-annually? So given R is 3,000, R is 9% or 0.09, M is 2, N is 6 payments. Then find the present value. So using the same process in example 5, again assuming that we already solved for the value of j, which is equal to 0.007363. So using the formula to get the present value, since it is one of the requirement, so you just replace all the given values in the given formula. So our P is equal to 17,545.09 pesos. So thus, the cost of TV set is 17,545.09. Okay, after our discussion regarding on how to solve the simple and general annuity and its differences, it is now your turn to do your task. So reminder, do not write anything on this activity sheet. Write your answer on a separate long bond paper. For enrichment activity 1, you fill in the blanks with the correct words to show how much you have learned. Write your answer on your answer sheet and it's give 1 point for each item. And for enrichment activity 2, answer the following problems. Show your complete solution on your answer sheet. It's give you 5 points for each problem. And for enrichment number 3, you solve the following problems. Write and show your solution on your answer sheet and then encircle your final answer. Each item give you 5 points. And for the wrap-up activity, fill in the blanks with the correct words to show how much you have learned. Write your answer on your answer sheet. It's give you additional 1 point in its blank. I hope you learned something today. If you have questions or clarifications regarding the topic we discussed, feel free to contact your subject teacher through text, call, or post your questions in your official FB group or page. Thank you for watching. Don't forget to like and subscribe.